Hi everyone. We will begin around 2 o'clock Central Time. Hi everyone, we will begin shortly. Hello, everyone. Welcome to the fourth virtual STEM Fair. Thank you all for joining with us today, and I hope everyone is doing well. Hi, my name is Shrikar Iranti, and I'm a sophomore, and I'm the organizer for this event. I wanted to bring the opportunity to other students to present and enhance their skills in STEM during the COVID-19 pandemic so that they can also develop their speaking and presentational skills. We have had three great events in the past couple of months, and the fifth event will be coming soon in November. And I have gotten amazing responses, and more events will be coming soon. See my website, stemfairs.com, for more details. We have a lot of exciting topics which will be presented in today's event, and we have a couple of exciting hours ahead of us today. But before we jump into those topics, we have some guest speakers today. One of the speakers is a professor at UIC, and the other speaker is from Purdue University. So now let's hear the first guest message speaker from Professor Gain.
Research assistant professor, and I work at the Learning Sciences Research Institute at the University of Illinois at Chicago. So this is our campus here in the foreground towards the bottom right, and then in the background you can see the skyline of Chicago. And what I want to talk with you about today is how I use STEM to understand and change the world. And I try to understand and change a particular small piece of the world when I'm doing this. And so really what I focus on is how do people learn new knowledge and skills? And I initially got my interests piqued in this general question in the process of learning to play a new musical instrument. And that sort of inspired me to understand how people learn new knowledge and skills in a variety of areas. So not only how they learn to play musical instruments, but for instance, how they learn to program a computer or how they learn to use a 3D printer. And not only am I interested in answering this question about how people learn new knowledge and skills, but I try to use that understanding to then help people learn. So I'm interested in answering the second question, how we can make learning easier and more enduring for students. And so to answer these types of questions, I adopt a psychological perspective. So I use the behavioral sciences to understand people's cognition and learning. And so to really understand how they think and learn in different areas. And part of this understanding really relies on fundamental issues of how people form memories, how they retrieve those memories, and how they manipulate those memories in something we call working memory. So I have to understand that. I also have to understand attention. So that is, how do people focus their attention at the task in hand and ignore distracting information? How do they engage in a process of problem solving in which they're bringing in the new information that they're learning and applying it to new problems? And then how do they use language, both to understand the content that they learned and to communicate what they're learning? So I bring in all these aspects of cognition and the study of learning, and I really study it in multiple different ways. And so to do that, I use scientific practices and the scientific process to understand thinking and learning. So part of this involves conducting investigations and experiments that are aimed at developing a better understanding of hypotheses and theories. And so sometimes this involves doing some experiments or investigations in a laboratory setting, as shown here, or sometimes these are actually done in classrooms with students and teachers as they're working and learning. I also collect, analyze, and interpret data to understand better about how people are learning and whether the things that we're doing actually help people learn. And in addition to that, from those understandings and those experiments, we can then develop models and explanations about how people learn and use this to then design better ways for people to learn. And so that takes me to the next point of what I really get excited about doing, which is putting all of this together. So what I know about cognition, what I know about learning, and the scientific practices to better understand that, in order to use all aspects of STEM to improve people's learning. And so here the challenge is to create materials and resources to help students learn and teachers teach. And so that's what I focus most of my work on these days. And so to do this, I really bring all of STEM together to do it. So I bring in the science knowledge that I have and the scientific practices that we know. I also introduce and use engineering processes. So oftentimes I'm in the work of developing products, resources, materials for people to use, and we use engineering principles, especially a focus on criteria and constraints in order to develop those materials. Now, oftentimes developing those materials and those resources for students involves an aspect of technology. So a lot of the tools that we develop are then implemented on the computer, oftentimes through websites or other activities and applications that students use. And underlying this all is mathematics that we use to help us understand and analyze the data that we're collecting and understand better about how to redesign these resources. So with that, I'd like you all to go forth and use STEM in whatever ways you can to understand and change the world. So thank you very much to Shrikar for inviting me to speak with you. And for those of you participating in today's STEM fair, thank you very much for your participation. My contact information is at the bottom of the slide. Feel free to send me an email or learn some more about the work that I do. Thank you very much. Bye.
Thank you, Professor Gain, for that. Now, our next guest message speaker is from Professor Brian.
Hello, my name is Dr. Lynn Bryan. I am the Director for the Center for Advancing the Teaching and Learning of STEM at Purdue University in West Lafayette, Indiana. I'm also a jointly appointed professor in the Department of Curriculum and Instruction in the Department of Physics and Astronomy. I would like to thank the organizer, Shrikar Iranti, for the invitation to send this message to you and to commend him for being a champion of science, technology, engineering, and mathematics by organizing this opportunity for all of you to share your passion for research in the STEM fields. I'd also like to commend all of you for entering your projects in this year's virtual STEM fair. In the few minutes that I have, I would like to share with you why the work that you are doing today is so important for the future for all of us. There's no question that we are living in a rapidly changing world that presents humanity with profound global challenges that defy simple technical and conventional solutions. In the 21st century, we are witnesses to grand socio-political technical issues ranging from overpopulation, global warming, climate change, and loss of biodiversity, to poverty, racism and prejudice, terrorism, and gender inequality. All of these issues require ambitious, principled, and ethical solutions that will have an impact beyond the boundaries of a single discipline or a single society. In the last decade, many organizations have identified issues such as those I just mentioned and call them grand challenges. For example, in 2011, renowned scientists and engineers, through a project by the U.S. National Academy of Engineering, identified more than a dozen grand challenges. For example, making solar energy economical, managing the nitrogen cycle, advancing health informatics, preventing nuclear terror, and more. In 2013, President Obama and the White House Office of Science and Technology Policy identified 4 grand challenges that the United States would prioritize during his administration: the BRAIN Initiative, the Sunshot Grand Challenge, the Asteroid Grand Challenge, and Grand Challenges for Development, a grand challenge consisting of 10 related challenges for making life better for children, their communities, and society. If you Google grand challenges, you will see that there are now many institutions, organizations, and professions that have identified these intractable but critical problems that defy simple technical and conventional solutions. and that require the ambitious principle and ethical solutions that will have an impact beyond the boundaries of a single discipline or society. So this is why your work today matters. By engaging in the type of work you are presenting today, you are building the foundational knowledge, skills, and practices that are needed to contribute to solving these complex, multidisciplinary grand challenges. You are building your future by pursuing your interests in STEM, even if you do not ultimately pursue a career in STEM. The knowledge, skills, and practices you are learning and developing today are transferable and useful in so many contexts. So you should be proud of the research that you are presenting today and be confident that you are making valuable contributions in STEM and ultimately to expanding our understanding of the universe, understandings that will hopefully make this world a better, more equitable, and sustainable place to exist. Good luck with your presentations and my best wishes to all of you.
Thank you, professors, for those amazing inspirational thoughts. So now let's take a look into topics that will be presented in today's STEM Fair event. First, we have wormholes in space. Next, we have introduction to AI, then microgreens, how Raspberry Pis work, and parts of a human body. So it looks like we have some great topics in store for today's STEM Fair. Also, check out my site, stemfairs.com, for information about upcoming events. Also, please remember that the event is being recorded and live streamed on YouTube. And the recording of this event will also be posted on my YouTube channel, STEM Explorers. So share the link with others and remember to like and subscribe. Everyone, please hold your questions until the end of each presentation and then type them in the chat. And I will ask them to the presenters. So now let's get started into the presentations.
Hello.
Our first presenter will be Romit, and he'll be talking about wormholes in space. So you can start presenting, Romit.
Hello, my name is Romit. I'm a 7th grader from Illinois and I go to Aptokisik Junior High School. Some interests of mine include cricket, soccer, drawing, painting, tennis, chess, and more. I hope you enjoyed this presentation. Wormholes. What are they? Wormholes are tunnels that connect 2 points in an imaginary fabric that people call spacetime. They can be viewed as shortcuts through space. Instead of traveling the entire distance, a wormhole acts as a shorter route. The history. The idea of a wormhole was elaborated by Albert Einstein and Nathan Rosen using the general theory of relativity, a mathematical equation found by Albert Einstein that has multiple solutions. It was originally called the Einstein-Rosen bridge. The Einstein-Rosen bridge was coined the name wormhole by an American theoretical physicist named John A. Wheeler in 1957. He called the Einstein-Rosen bridge a wormhole because of how a worm chews a hole from one end of an apple through the center to the other side. That would create a bridge. An ant could then choose to either go half the circumference of the apple or go through the hole that the worm created. Thus, it was called wormholes after that, because of the resemblance to the shortcut made by worms. Number 2, how could wormholes work? As I said earlier, a wormhole is like a bridge that connects two different points in the fabric that we call space-time. Like a bridge, a wormhole needs two ends. Those two ends are called mouths. So, a wormhole could theoretically be a black hole. It could have a white hole. So a wormhole could be two black holes, it can be two white holes, or it could be one side with a black hole, while the other side has a white hole. A black hole is a point with such immense gravity that nothing can escape from its grip. Not even light, the fastest thing that we know, can escape. We don't know what happens inside, but we can guess that the black hole rips everything apart. We can guess this because scientists have noticed that stars suddenly get sucked up by an invisible force. There are three types of black holes: primordial, stellar, and supermassive. A primordial black hole is thought to form soon after a Big Bang. A stellar black hole is created when a star dies in the form of a supernova. Scientists think that supermassive black holes formed at the same time that the galaxy that the black holes that were created were in. A white hole is another solution to the general theory of relativity. An Austrian physicist named Ludwig Flamm realized that a new solution was possible. He called the solution a white hole, the opposite of a black hole. A white hole spews things out, and nothing can come into it. Coming back to wormholes, the wormhole that we would be able to use would be the third option, a black hole at one end and a white hole at the other. We could use only these because a black hole can only suck things in and white holes can only spew things out. So any other option wouldn't work. Number 3, what it would look like. As I said, a wormhole is like a bridge or tunnel. As you can see here, the wormhole clearly looks like a tunnel. Another way that you can look at it is like the imaginary fabric called space-time is a piece of paper. If there are 2 points on the same side of the paper, you can fold the paper and line up the points. Then you could poke a hole through the 2 points. That tunnel acts like a wormhole, since wormholes also connect 2 points in space-time. And as I said before, act as a shorter route. Here in the second picture, you can see that there's an event horizon in the black hole and the white hole. In the event horizon of a black hole, nothing can come out of it. And outside the event horizon of a white hole, nothing can come in. The point where the black hole and the white hole touch is called the singularity. Number 4, where would it be? A wormhole could be in a lot of places. For all we know, there could be one right outside our solar system. What we do know is that the nearest found black hole is in the constellation Telescopium. That's about 1,000 light years away, or approximately 5.879 times 10 to the power of 15 miles. Another way to say that is 5.879 times 100,000,000,000,000,000,000,000,000,000. That's a lot of zeros. Yes, that's correct. 1,000 light years away, or 5.879 times 1 quintillion. Now you might be asking, what do you mean by found, Romit? You may ask. Well, the reason I said found is because black holes are very, and I mean very, hard to find. As I said previously, nothing can escape black holes. Not even the fastest thing that we know of, light, can escape the gravitational pull of black holes. Thus, we can't see inside black holes. NASA.gov says a black hole cannot be seen because of the strong gravity that pulls all of the light into the black hole's center. However, scientists can see the effect of its strong gravity on stars and gases around it. If a star is orbiting a certain point in space, Scientists can study the star's motions and find out if it's orbiting a black hole. When a black hole and a star are orbiting close together, high energy light is produced. Scientific instruments can see this high energy light. This is only one of the ways that we can find a black hole. Thus, for all we know, as I said before, a black hole could be lurking right next to our solar system and we wouldn't even have noticed. Now, I know some of you may ask, will the sun ever turn into a black hole? And the answer is no. The sun doesn't have enough mass to create a supernova. And without a supernova, you can't create a black hole. Number 5, how long would it take to go to a black hole? As I said, the nearest found black hole that we found is 1,000 light years away. A light year is the distance that light can travel in a year. And Albert Einstein says that the speed of light is the maximum speed that we humans can travel. So even if we travel at the speed of light, we will take 1,000 years to go to the closest found black hole. That is a lot of time. 1,000 years is about 30 generations. Humans have only been around for about 200,000 years. So we would take 1/200th of the amount of times that humans have been around to go to a black hole. But as I said before, there could be a closer black hole that we don't know of. Number 6, are they safe? A wormhole is very unstable and they would collapse almost right away, right after they form. Even light wouldn't have enough time to go through a wormhole. So there's a lot of chance that if you do try to go, you'd be trapped inside. We also don't know what happens inside a black hole past the event horizon, because as I said before, even light can't escape. But we do know that you would be shredded into pieces. There's also a huge chance that white holes don't even exist. They wouldn't exist because white holes are against the laws of physics. An example is that the black hole is like a wood chipper, and when you put a piano in, it gets chipped. A white hole would be like the wood chipper, except when you put the chips in, the chipper turns those chips into a weird, damaged piano. But quantum mechanics says that white holes could exist inside black holes. Number 7, will they ever be useful? Wormholes will not be useful as far as we know, due to them closing too fast to actually travel. As I said, white holes might not even exist at all. Also, wormholes would be one-way tunnels because black holes can only suck things in and white holes can only spew things out. They would also be way too far to travel. Also, anything that comes out of a white hole will be a very mangled version of the original. So even if a white hole does exist and so does a wormhole, the thing that would come out of a white hole wouldn't be you, but pieces of you that's severely damaged and cut. White holes are still purely hypothetical. The only way that white holes can be open long enough to travel through would be to find exotic matter. Exotic matter is supposed to have a negative charge, meaning that it has a negative mass. It's a very abstract idea. Like we know, normal mass has gravity and pulls things in, just what planets and stars do. What exotic matter does, though, is it repels objects. So just the right amount of exotic matter would keep a wormhole open, because the exotic matter would push the tunnel open. But we don't even know if anything like that even exists. Even if it does, it would be very hard to move it, because the exotic matter would repel anything that we use to move it. Also, the spacecraft, spaceships, and rockets we would use to go through a wormhole would be repelled by the exotic matter. So, we would still not be able to use a wormhole. All in all, we might never be able to travel through a wormhole. Any questions?
Thank you, Romit, for that amazing presentation. Now, if anyone in the audience has any questions that they would like to ask, please type them in the chat and I will ask them to Romit. I'm not seeing any questions right now. I'll wait one more minute. Okay, Roman, I don't see any questions. Thank you, and you had an amazing presentation. Our next presenter is Shripada. She will be presenting about artificial intelligence. Shripada, you can start presenting now.
Artificial intelligence. Artificial intelligence is not only about technology, robots, relationships, it is also the manifestation of the world. Artificial intelligence, or AI, according to Oxford Dictionary, is the study and development of computer systems that can copy intelligent human behavior in all sorts of industries or fields, like technology, healthcare, transportation, manufacturing, and education industries too. In shorter words, it is a substitute for humans. Is AI beneficial for us? Well, Albert Einstein once stated, "It has become appallingly obvious that our technology has exceeded our humanity." This quote shows that AI and all kinds of other technology is improving humanity. But on the other hand, Elon Musk, CEO of SpaceX, once stated, "With artificial intelligence, we are summoning the demon." This quote indicates that AI will bring destruction. But who is correct? Which is correct? To figure out whether AI is beneficial for us or not, let us explore its pros and cons. To begin with, let us explore some of the main pros of AI. One of the most trending things in today's world is technology and its development. As a matter of fact, AI is already helping with that. An example would be the Tesla car. This incredibly special car can drive on its own using AI. When this car is on autopilot mode, it can think up to nearly 1,000 predictions of what can happen around it. It makes sure that it is driving correctly in all possible ways. This creates an exceptionally low chance of an accident to occur. In the end, the car is prepared for anything and hopefully everything, which makes a much safer and efficient ride for the people inside of it. Another thing AI is and will be used for is for phones, computers, and other technology like that. These days, technology is allowing face recognition. In this way, the right people have the ability to access their phone by simply looking at it instead of typing in a big old password. Isn't that just so convenient? Another key part of today's world is healthcare. AI can also help in that industry too. How? Well, AI can help with operations, surgeries, and maybe even diagnostics, making our healthcare system so much more accurate. To add on, AI in healthcare will speed up the process so much. As a matter of fact, doctors or nurses must fill in data for each and every patient that they receive. This can take a really long time, but with the help of AI, this can be done within seconds. And doctors and nurses will be able to access the information, making healthcare a lot more better. Not only that, AI can also do important operations with no flaws at all. This will ensure the safety and convenience of all patients. Another key thing to our world is transportation. With the help of AI, transportation will become so much more earth friendly because AI will not use any fuel like fossil fuels and oil. It will use electricity. Not only that, humans won't need to be stressed about driving it because AI has it covered. It can drive on its own. This can create an exceptionally low chance for an accident to happen, like I mentioned before. Not only that, transportation with AI will become so much more faster, leaving you at your destination in no time at all. To add on, vehicles will look a lot cooler too. Another key thing to today's world is manufacturing. AI can manufacture things a lot faster, making our supply for the mass population within just a few clicks. Now that was easy. Not only that, AI will help businesses, small and big, expand in no time at all. And AI can and will totally meet the needs of the entire world population in the future. Imagine yourself walking into your math classroom only to find a robot writing the problems we will be solving today. Weird, isn't it? Well, in the future, teachers will be robots. They will teach us all that we need to know. There are many benefits to this. Like what? One way is that they can explain more thoroughly. This means that the solution will be explained in many ways, which will help students have different ways to approach or tackle the problem and see which one works for them. Not only that, AI can teach one on one at any time. This will help each and every student in their specific needs. Today, we do get one on one time with our teachers, but AI can do it a lot more efficiently, which makes education so much more better. Okay, now that we have explored some of the main pros of AI, let's switch to the cons. One of the important things for humans is emotions. We can be happy, sad, mad, and etc. But can AI? The answer is no, no, and yet another no. Because AI is built mostly for doing work, and they are programmed in a certain way. Whatever they are programmed to do, they will do it. Nothing less, nothing more, which will discriminate emotions. And even if AI did somehow have emotions and they could somehow have the ability to understand you, will you be okay in telling a robot how you feel? Most likely not. We would feel more comfortable in telling your feelings to someone you really know and trust, like your parents or friends or etc. This shows that AI is not going to help us emotionally, which is one of the most important things to humans. It makes us unique. Does anybody know why we get educated? Well, the answer is to get a decent job and settle. However, if AI is there doing all the work, then what will we do? I know, get unemployed. In the future, the unemployment rate will go zooming high and everybody will be looking for jobs. Why though? First of all, AI is capable of doing a job accurately, efficiently, and with great speed. Humans are not capable of doing all of these things, which makes AI more in demand. And humans will be unemployed because of that. As a matter of fact, everybody used to have at least 60 minutes of exercise each day. When AI becomes more and more popular and makes its way into our homes, we won't be able to do much of that. Why? Well, AI will be there for our luxury. This basically means that AI is going to do all the household things like cooking, cleaning, vacuuming, and etc. Wait a minute, if AI does all of this stuff, then what do we do? Duh, get served. Wow, what an exercise. This is not an exercise. AI is simply going to prevent us from being healthy and make us lazy. AI is surely not a good substitute to humans. Artificial intelligence is totally different from humans. We have moral values. We can't teach AI this stuff because this comes with true understanding, with experience. Not only that, we can differentiate between right and wrong, but AI can't. To add on, we have the ability to understand others and express emotions. But AI can't. But no matter what, disregarding the pros and the cons, AI is and will be a surprise for one and all, with surprising inventions, fascinating discoveries, and so much more. So, AI may bring the world to an end, but it may help us prosper. We just need to wait and see. Thank you. Any questions?
Thank you, Shripada, for that amazing presentation. So now if anyone in the audience has any questions, you can just type them in the chats. Let's wait a few minutes and see if any come in. So someone is asking, what do you feel about AI? Do you think it's gonna be beneficial to humanity, or is it gonna make humans like not as good? So what's your thought on that?
In my opinion, I think that AI will most likely bring the world to an end because of its special features and its knowledge. Like it's programmed to learn from its mistakes, which will make it so much more superior from humans. And eventually it will have enough knowledge and power to take over the world. So not only that, it doesn't have emotions and all of these things that make us humans special. So in my opinion, I think that AI is going to bring the world to an end, and it's not a very good substitute for humans.
It's definitely an interesting take on the topic. Thank you, Shripada, for your for presenting today. Our next presenter will be Akshita. She will be talking about her garden, and it's a very interesting presentation for sure.
Hi everyone, my name is Akshita Sishal and I am in the 6th grader at Aptakisik Junior High. And today I bring this presentation to you to talk about my special element in my presentation today, microgreens. So this is my agenda for today. You can take a look at it.
Sorry, Akshita, there's a problem with your screen sharing. I'm sorry for interrupting you. Can you please try again?
Sure.
Yep, we can see it now.
Okay.
Sorry for the interruption.
No, it's fine. So hi everybody, my name is Akshita Sishal and I am in the 6th grader at Aptakisik Junior High. And so I'm bringing this presentation to you to talk about my star element in my presentation, microgreens. And this is my agenda for today. You can take a look at it. Okay, so this is a picture of microgreens so that you can visualize in your head while I'm going to be talking about microgreens. All right, let's get started. So what are microgreens anyway? So microgreens is a stage of a plant when it's in between a sprout and a baby green stage. All a sprout is when a seed germinates and it has its first stem growing out of the seed. A baby green stage is when its plant has its third set of leaves. And if it's hard to think about this, then think about it as in between a baby and a toddler. Microgreens have an aromatic flavor and a rush of deli freshness. They carry millions of nutrients upon their backs, and they also have something called polyphenols. Polyphenols is a class of antioxidants. We're going to be talking more about them in the health benefits slide. The specialty about microgreens is that they're grown throughout the year. And if in a very cold place, microgreens are grown with an ultraviolet light or a grow light. So you might be thinking, why did I include microgreens in a STEM and science fair project? Well, microgreens are a type of plants, and plant science is also called botany. And botany is the branch of biology that handles the study of plants. Biology is the branch of science that handles the study of living organisms and their properties. A person who studies botany is known as a botanist. Botanists can either stay indoors and research in a research lab, or they can go to the great outdoors and research out there. Botany also includes all sorts of interesting plant-like organisms, such as algae, lichens, ferns, along with the actual plants and flowers. But later in the science lab, it was observed that algae and fungi belonged in a different division. I'm going to tell you an interesting fact. Did you know that science of plant life was actually discovered about 500 million years ago? Yeah, and the first plant discovered is the lycophytes, and they're still around today. These lycophytes are a type of plant, and some of these lycophytes then evolved to become scale trees. These scale trees, sadly, are now extinct. So you might be thinking, how are scale trees extinct, but lycophytes still around? Well, that's because at that weather, it could evolve to become scale trees, but we don't really care the same weather and condition. So that's the reason. Now back to scale trees. So did you know that scale trees then covered the earth to a thick forest? And some people even call these cold forests, because since they were so dense that when they fossilized, they turned to look like a seam of coal. And this period is known as the Carboniferous period. Another fun fact is that Theopartus, one of the earliest botanists of the world, is known as the father of plants, due to his major writing skills in botany. All right, so why should we choose microgreens in the first place? I mean, you should have a reason, right? Yeah, well, microgreens are super nutritious too, and they also have a lot of interesting things to learn about. That's why I chose this topic today. And they're also very practical to grow. I mean, they only take 2 weeks to grow, and you don't even need any materials. All you need is some seeds, some pots, and some soil and water. All right, so let's talk about the health benefits. Remember how I talked about polyphenols? So we're going to be talking a lot about it in this health benefits slide. Just note down that these are only a few of the health benefits of microgreens. There's so many more. So, as I said, polyphenols is a class of antioxidants, and it's linked to lower the risks of heart disease, of some types of cancers, diabetes, and a disease called Alzheimer's. Animal studies prove triglyceride, a kind of bad LDL cholesterol level, can also be lowered by microgreens. And microgreens are also prosperous in potassium, iron, zinc, magnesium, and copper. All right, so I have another slide to show you too. So this is now for the real example to make your own miniature garden at home. And all you need are some more normal materials that you have inside your house. You have some pots or food containers that you probably got at the restaurant for takeout. Just make sure they have holes in the bottom of the pots, or else they might not drain out the water. And you'll need some seeds. And that's the good thing about microgreens. You actually don't need to go to the store and buy seeds. You can just use seeds from fruits, vegetables, lentils, or grains. You'll need some sunlight, and part of the procedure, you'll also need a window so that you can keep it inside. Or you can just use the ultraviolet light or a grow light. You'll need some water, and of course, smiles to help our plants grow. So, how do you do this? This is the procedure. So you can either germinate or soak your seeds. But you might be thinking, what's germinating? As I said, germinating is basically just making your seed sprout. So it has that white stem growing out of it. And you can either do this by taking a Ziploc baggie, adding in a damp cloth into it, add your seeds inside, and then wait till they sprout. Or you can soak your seeds. But before adding your seeds into the soil, you'll need to wet it. To do that, just add water into a spray bottle, or evenly spread water with your own hand. And then make sure to cover your seeds with some more soil. And make sure to water the plants each day to avoid arid and thirsty seeds. But on the first 1 or 2 days, try to keep the seeds inside with a grow light or a bright windowsill for a healthy seedling. Then, after that, put the plant outside in the sunlight for a natural seedling. Or you can keep on using the grow light. So now I have a video to show you about the way I grow my microgreens. These are the seeds that we're going to be planting. This is horse gram, this is chickpea, this is fennel, That is fenugreek. This is coriander seeds, and these are mustard seeds. So, we're going to be soaking these two, chickpea and horse gram, overnight, and then we're going to be tying in a damp cloth so that, because these are hard-shelled seeds, and these will not plant through as the other ones. So let's do that. I'm going to be soaking my horse gram and my chickpea seeds. So for my horse gram seeds, I'm going to be soaking it with 100 milliliters of water, and for my chickpea seeds, 150 milliliters of water. I'm going to let these both soak for 5 to 7 hours, and then I'm going to be covering these seeds with a damp cloth overnight. And let's see how that turns out in the daylight. Your soil. And you're done. Now, after you've added your soil to all your pots, make sure if you are using soaked seeds, then reserve a few pots so that you can add your soaked seeds onto your pots later. Now I'm going to be using the seeds that I haven't soaked, which is like cilantro that I'm having right now. I'm going to take some cilantro and sprinkle that on top of my pots evenly. And just make sure that it's very nice so that you don't so you have it around the area. Then cover your pots with soil so that it can grow fully, and do this with the rest of your pots. Now we're done. Do the same as I did with the coriander seeds. Now get the others done too. This is the progress report of 2.5 weeks of my microgreens. So here we have full-grown horse gram, chickpea, we have fenugreek, and we have mustard. Now let's go harvest them. Now after you've harvested your microgreens, you can make your own mini dish out of them. I chose to make a microgreen salad and some dal with some microgreens. Okay, so you might be thinking, well, how does this all happen? Surprisingly, it just all starts with a tiny baby seed. So I'm going to be showing you a diagram of the seed. So do you see this brown layer here? And that is called the seed coat. And that's that coat around the seed, which makes it have a shell around it. And this yellow area inside the seed is called the food storage. And this food storage, when the seed goes into the soil, it sucks up all the nutrients and minerals from the water in the soil, and it starts like sucking it up into this yellow area called the food storage. It has it in the name. It's a food. It's a storage for food. And then this main element, the embryo, and this is our future plant. So it starts eating up all these minerals and nutrient delicious stuff, and it's going to start growing. So you might be seeing that little sprouting. It starts to sprout, and then it starts anchoring down its roots until you have your plant, or in this case, our microgreens. So I'm going to talk about the microgreen industry. And this is a really interesting and an important topic that you should learn. And I think it's interesting. Microgreen industries have been in business for generations and generations to come. And they make profit from just 2 weeks. And they have partners in business to cope and make decisions to grow their industry to a bigger industry one day. Their priority goal is to grow and sell microgreens at a reasonable rate. They choose worthy restaurants and grocery stores to sell their fresh delights. They use about reasonable space, time, and money for their business. And in return, they get back their money, and the company will keep doing its thing, all in all, and the grocery stores and restaurants will cope and get what they want at the same time. Did you know microgreens can make a good income in a very small space and time? A capable grower can produce and harvest 80 to 100 crops a year. Since microgreens are in high demand, 1 pound of microgreen is going to be worth $25, and 50 pounds would be worth $1,250 bi-weekly. And did you know the microgreen industry will increase by 7.5 by 2020 to 2025? Yes, since the high rate trading happening in North America right now is very high now, we will have a very high rate in the microgreen industry in the beginning of 2025. All right, this is my favorite part. my interesting brain twisting facts. So, first one, why do onions make us cry? Well, onions have an element inside them called sulfur, and when the sulfur comes out, it tries to tear up our eyes. So, where do bananas come from? So, you might be thinking, and you might realize this now, that your banana actually doesn't have seeds, or those specks inside your bananas actually aren't seeds. Well, they're seeds, but they're unformed seeds, so you can't grow with them. So, what growers do is they take a tiny part of the the tiny part of the soil under the banana plant, and they reproduce it over and over again. Did you know strawberries aren't even berries? Yes, actually, bananas are berries, though. You might be thinking, why do apples float when you're bobbing for apples in Halloween? Well, actually, apples have 25% of air in them. That's what makes them float in water. Do you feel happy while eating a banana? I sure do. And also, scientists prove that inside a banana, there's an element that tries to make you feel better while eating a banana. Well, I'm going to eat a banana right after this presentation. Why do apples or any other fruits or other plants taste different than each other? Well, actually, they're basically not the same plant. So they're different plants all in all. But basically, that's the topic. So thank you for watching my presentation. Thank you, Shrikar, for letting me present in this presentation today. And do I have any questions to answer?
Thank you, Akshita, for the great presentation. Now, if anyone in the audience has any questions, you can again type them in the chat. I'm not seeing any right now. Let's wait 1 or 2 more minutes and see. So someone is asking, isn't it easier to grow actual plants?
So to the answer to that question, from my perspective and my opinion, is actually it is easier, though what will happen is that when you look at it in that way, it actually takes a pretty much longer time. And for example, it actually won't take like 2 weeks to grow, because microgreens actually just take 2 weeks to grow, and you don't really need all those other equipments. Like sometimes if you want to grow like broccoli or something, you'll probably go to the store and buy some broccoli seeds or another plant or something, or for flowers. So microgreens just make it easier, and they're really interesting, because they're like a tiny bite-sized thing that you can add to your diet, and they taste like other elements, like other plants too. So I think I like it, but I guess you can choose both of them.
Okay, thank you, Akshita, for your amazing presentation. So our next presentation is from Dev. Dev will be presenting about the Raspberry Pi, and he is from Texas.
Hello everyone, my name is Dev Mansinka and I'm from Texas and I am in 7th grade and today I will be presenting about Raspberry Pi. The Raspberry Pi is a series of small single-board computers that can do many things. You might look at the picture on the bottom right and think that it's nothing like a real computer you have seen before. Well, actually, the Raspberry Pi consists of all the same critical components that your actual computer has, just in a way smaller and more affordable version. Now, here are some fun facts. The Raspberry Pi was first created in 2012 to start the innovation with computers again, because after some other devices had been created, people had stopped coding and everything. So that's why the Raspberry Pi was created, so that people could become more innovative with computers. And the Raspberry Pi is as small as a deck of cards, and it costs around $30, so it's very cheap. So in the last slide, I might have said that the Raspberry Pi is a series of single board computers. You might be wondering what a single board computer is. Well, the name pretty much gives you the answer to that question. It is a computer built on a single circuit board. A circuit board is a thin board with an electric circuit in it. The Pi is one of the most popular single board computers. There are many other companies that have tried to create something like the Pi, like Arduino boards, but the Pi still remains one of the most popular ones. Now, I'll tell you about some of the features of the Raspberry Pi. The features vary based on the model of the Pi, but these are the features that all the Pis usually have. Some of them might not be there in some other versions, but that depends. The USB ports. The USB ports are used to connect the mouse and the keyboard. These can also be used to connect other things like the USB drive or any other thing you might want to connect using USB. Next is the SD card slot. You can put the SD card in here. This is where the operating system software files are stored. The Ethernet port. The Ethernet port is used to connect the Pi to the network using the Ethernet cable. You can also use wireless LAN to connect the Pi to the internet. There's also an audio jack in which you can connect the headphone for any projects involving sound. Let's continue looking at the features of the Raspberry Pi. Looking ahead is the HDMI port. This is one of the main things because this is where you plug in the monitor or whatever you're using to display the output from the Raspberry Pi. If your monitor has speakers, you can also hear the sound. In the micro USB power connector, you can connect the power supply for the Pi. It is recommended that you do this after all the other parts are connected so that the power doesn't start and then you actually have time to connect everything else. Next is the GPIO ports. You can use the GPIO ports to connect extra electrical components that you might need for your project, such as LEDs or other buttons. Now, the Raspberry Pi, since it's a very small computer and a mini version of it, it doesn't have a lot of power in it. That's why it can burn out very fast, and that is one of the main reasons that connecting the power in the end is recommended. Now, let's have a tour of the Raspberry Pi. Setting up the Raspberry Pi is a very easy thing. After connecting the keyboard, mouse, and the monitor, you can turn the Pi on. Then you can install the operating system that you want. It's usually the Raspbian. That is the recommended operating system for the Raspberry Pi. After the OS is installed, updated, and set up, you can do anything on it. You have just made yourself a mini computer. You can search, edit text, or do anything else that you would do on a normal computer on this. If you want, you can also code the Pi to do something else. Like in Windows, you have the start key to get to other tabs or the other apps in the operating system. Here you click on the Raspberry Pi logo to get to the other apps available in the operating system that you have installed. Now let's look at some of the example projects that are very popular. Now, there is a very, very huge variety of projects that can be created. The smart mirror is one of them. It shows the day's basic information. Example, the day, date, time, weather, and basic news headlines. The mirror is basically a wooden frame that is made like a box from behind. Inside the box, you have a monitor, which is coded to show all of these information in a specific layout. Then you add a mirror inside this in the front of the box, and then the mirror is just reflective enough so that you can see yourself, but it's also transparent enough so that you can see the information on the monitor right behind the mirror. After you code the Pi, you can connect it to the monitor using the HDMI cable. The second example project will be the Raspberry Pi CCTV camera. In this, you need a camera module and a motion sensor. Then you code the Pi to start recording after the motion is sensed using the motion sensor. Then, after you decide where you want the recording to be stored, you can put the camera anywhere in the room. This is a very simple but an interesting project that you can do. Thanks for watching. Now, do I have any questions?
Thank you, Dev, for your presentation about the Raspberry Pi. So now, if anyone in the audience has any questions, please type them in the chat. Oh, I already see that I have a question here. So someone's asking, what's a good operating system for the Raspberry Pi? What would you personally say is like pretty good for it?
Well, after you connect the Raspberry Pi to your monitor, it will ask you to install an operating system, and you will see a whole list, and you will see what each operating system can do. But the most specific or the most recommended one is the Raspbian. The Raspbian is the operating system that is the most common when you're using the Raspberry Pi, since it's an operating system specifically created for it.
Okay, thank you for answering that question. The next question in the chat is, can you create a full computer with the Pi? And then the second part of that question is, can you make a laptop from the Pi?
Well, yeah, you can easily create a laptop. I don't know if you like talking about, I don't know if the person asking the question is talking about coding it to do things like a laptop. But if you connect the Pi to a monitor, then connect it to a keyboard and a mouse, you easily have yourself a computer that will do anything like a laptop can do after the OS is installed.
And last question here, how much does the Raspberry Pi cost once again?
On the first version, it ranges from $5 to $75. It's very cheap. And if you want to do projects, you can buy the other materials for the project. But just the Raspberry Pi is costing between $5 to $75.
Okay, those are all the questions. Thank you, Dev, once again for presenting. You did great. So the next presenter is Rashab. He will be talking about parts of the human body. So Rashab, you can start presenting now.
Hi, the human body. Hi, my name is Rashab Raprati. I will be explaining about the human body, its systems, and their functions. These are the topics I'll be explaining today. Take a quick peek at it. Anatomy is a study of the human body. The bodily systems inside a human all work together to keep your body working, safe, and healthy. Our body has trillions of cells that work together to form our bodies. Many cells of the same kind working together form bodily tissue. Many tissue working together form an organ. Organs working together form bodily systems. Many systems working together form our bodies. The systems in our bodies include the nervous system, the circulatory system, the respiratory system, the digestive system, the endocrine system, the immune system, the urinary system, the skeletal system, and the muscular system. The nervous system. The nervous system consists of the brain, the spinal cord, and nerves. The brain is like the control center of our body. It can control anything from our skeletal muscle to our heart rate. The main part of the brain is called the cerebrum and is split into two parts. The left part controls the right side of the body, and the right side controls the left part of the body. The base of the brain, the cerebellum, controls coordination and fine movement. Nerves are wires that carry electrical signals across the body. Nerves are made of special cells called neurons. Neurons are long-lived and some are never replaced in a lifetime. The brain fires the electrical signals as I speak. The signal travels through a nerve. The signal stimulates a muscle. If a muscle gets stimulated, the muscle moves. The circulatory system. The circulatory system consists of the heart, the veins, and arteries. The circulatory system's job is to deliver oxygen throughout the body. The heart pumps blood throughout the body since blood carries oxygen. Oxygenated blood flows through the arteries while deoxygenated blood flows through the veins. When oxygen gets to the body parts work efficiently. Blood contains hemoglobin, the chemical which enables it to carry oxygen. When we breathe, the lungs collect the oxygen for the blood to collect and deliver throughout the body. Deoxygenated blood carries carbon dioxide to the lungs to let it go. We cannot live without blood. Since blood carries oxygen to vital organs, without blood, the oxygen cannot get delivered. The respiratory system. The respiratory system consists of the lungs, the trachea, the bronchi, the pharynx, the nasal cavity, and the larynx. The respiratory system's job is to get oxygen from the air and give to the blood cells so the blood can deliver oxygen to all the body parts and remove waste carbon dioxide out of the body. We do this by inhaling and exhaling. The lungs aren't muscles. We breathe because of a muscle called the diaphragm. When we breathe in, the diaphragm contracts. When we breathe out, the diaphragm relaxes. We can breathe in through our nose and mouth. Most people breathe in through their nose, but if they're congested, they breathe through the mouth. Air travels through the trachea, through the bronchi, and into the lungs. The digestive system. The digestive system consists of the esophagus, the stomach, the pancreas, the liver, the gallbladder, the small intestine, the large intestine, the rectum, and the anus. The digestive system is to retrieve nutrients from the food we eat and remove the food as waste when it has collected all the nutrients from the food. The stomach breaks down the food so it is easier to retrieve the nutrients. Then the liver retrieves the nutrients from the food. When the liver is done processing, the food goes into the small intestine. There, the broken down food still has some nutrients. In the small intestine, the food is reduced of its nutrients because of friendly bacteria. Then the food travels through the colon as feces. The endocrine system. The endocrine system consists of the thyroid, thymus, testicles, ovaries, uterus, pancreas, hypothalamus, pineal gland, and the adrenal glands. The endocrine system's job is to produce hormones to keep the body working. A hormone's job is to stimulate a certain tissue or cell into working. Growth hormones such as testosterone and estrogen are used to build male and female characteristics in the body. For example, insulin's job is to regulate blood sugar levels. The thyroid produces growth hormones into the bloodstream. That is why someone with hyperthyroidism grows very tall. The immune system. The immune system consists of the tonsils and adenoids, the lymph nodes, the lymphatic vessel, the spleen, appendix, the Peyer's patches, and bone marrow. The immune system's job is to fight off invading foreign pathogens. White blood cells flow in the bloodstream to fight off invading pathogens. White blood cells are produced by the bone marrow as well as red blood cells. 5 types of white blood cells include lymphocytes, monocytes, neutrophils, basophils, and eosinophils. There are 2 types of lymphocytes, T lymphocytes and B lymphocytes. If the body recognizes the invader and its antigens, the outside spikes on an invader. The body will then launch antibodies. An antibody is a type of chemical that latches onto an invader's antigens, killing it. The urinary system. The urinary system consists of the kidneys, the ureter, the bladder, and the urethra. The urinary system's job is to clear all toxins out of the bloodstream. When blood flows through the kidneys clear out a toxin called urea and other toxins out of the bloodstream. When the body wants to get rid of the waste toxins, it is released as a liquid called urine. The kidneys are important since they filter blood. The ureter carries urine into the bladder. The bladder holds urine until it's ready for discharge. The urethra discharges urine. The skeletal system. The skeletal system is what gives us the ability to move around. Without our skeletal system, we wouldn't be able to move. We wouldn't have a posture. We would be like a stiff blob. Our skeletal systems are made of bone, unlike cartilaginous animals like sharks. Bone is 5 times as strong as steel, but they can still be broken. Bones get their strength and rigidity from hard deposits of calcium and phosphate. Bones get their flexibility from collagen, a tough rope-like fiber. Special cells called osteoblasts make new bone cells, while cells called osteoclasts eat worn out or old bone cell. When we exercise, our bones and muscles get stronger, but putting too much pressure on the bones can also damage it. The muscular system. The muscular system enables us to move around, just like the skeletal system does, but without a muscular system, we would literally be skin and bones, unable to stand since the muscles also enable a person to stand. There are 3 types of muscle: skeletal muscle, smooth muscle, and cardiac muscle. We can control our skeletal muscle. We are aware of this kind of muscle moving. Cardiac muscle isn't controlled by the brain. It is found in your heart and keeps beating. Smooth or striated muscle is found in organs such as the stomach and intestines. Smooth muscle is controlled by the brain, but we are not aware of it, unlike skeletal muscle, which we are aware of moving. The five senses. The brain is linked to all our senses. Our five senses are sight, hearing, smell, taste, and touch. When we see upside down. The brain gathers what we see and turns it the right way. When we look at something and we have to figure out what it is, our brains gather previous memories containing that item. Then we know what it is. Our ears can hear up to 20 to 20,000 hertz and 0 to 100 decibels. If we look at what is making the sound, it makes it easier to know or remember what it is. Because of the olfactory bulbs, we are able to smell. A normal reaction is if we smell something good, our brains tell us to keep smelling it. On the other side, if we smell something bad, our brains tell us to cover our noses. If something is smooth, since our brain knows it won't do any damage, we keep feeling it as it feels good. But if we touch something sharp or painful, our sensory nerves relay the pain information to the brain. Then the brain tells us that item will damage the body. As a reaction, we feel pain. We can taste five things: sweet, salty, bitter, sour, and umami. Umami means delicious in Japanese and defines food like meat, mushrooms, and cheese. Thank you. Hope you enjoyed the slideshow. Open for questions?
Thank you, Rishab, for your amazing presentation. Does anyone in the audience have any questions? If so, please type them in the chat. So one person's asking, how many systems are there in total?
How many systems?
Yes, like body systems.
In the agenda, it shows we have the nervous system, number 1, the circulatory system, number 2, the respiratory system, number 3, digestive system, number 4, endocrine system, number 5, the immune system, number 6, the urinary system, number 7, the skeletal system, number 8, the muscular system, number 9, and I didn't include this one, the reproductive system. So all in all, we have 10 systems total.
Okay, those are all the questions that I can see in the chat. Thank
Okay.
you, Rishab, for your amazing presentation.
Okay, thank you.
I hope everyone had a great time, and I hope that you all learned something new today during today's STEM fair. And thank you to all the viewers on Zoom and on YouTube Live. And I see many thank you notes in the chat, and I'm glad to see them. And it was my pleasure to organize this event. So in 2 months, there will be a fifth STEM fair in November, and there are also going to be more event dates announced soon. So in the center of the slide, you can see a sneak peek of some topics that are coming up in the future events. One of them is black holes, the Internet of Things, AI, and there are more topics coming soon in that event as well. And if you want to sign up as a presenter, you can go to stemfairs.com for that information, and the links to sign up are also on that site. Currently, there are still slots open for the November event to sign up as a presenter, and you can sign up for more future events. If you have not yet signed up as an audience member and you want to watch future events, you can also sign up at my site, stemfairs.com. Also, you can check out my YouTube channel, STEM Explorers. I will post this event there. So if you came late or if you want to watch a section of it again, you can go watch it on my YouTube channel, STEM Explorers. And during the last event, many people asked me questions on how to sign up and what my process was and how I helped the presenters create their presentations through the process. So I thought that I could answer those questions by providing some details. So first, a bit about me. I am a rising sophomore and I have been presenting since 4th grade in various SIT conferences and maker fairs. I am also on my school's VEX robotics team and I love exploring new technologies and coding and doing CAD. So why am I doing this then? Well, as I said before, I wanted to bring other students the same opportunity of presenting about STEM even during these special circumstances, and now I am organizing these events online. So now let's get into the process of signing up and how to be a presenter. So let's begin at my site, stemfairs.com. It has all the information about the event and links to sign up. So let's go to the website. So this is my website, stemfairs.com. And here you can see the homepage, and then scroll down to site content to go to sign up. And then you will be taken to a sign up page where you can sign up as a presenter. And then you can simply go through the form, and then I will contact you and I will help you choose a topic. So now back to slides. So for those who sign up as a presenter, the first step is choosing a topic. It can be any STEM related topic, and the topic has to be important to the presenter. So if they ask me for a topic, I ask them what they are passionate about and what they want to learn more about. And as I said, if you need help choosing your topic, I can guide you through that. The second step is to research about the topic. Use good sources and maybe even some different articles or scientific papers. And if a presenter has trouble starting their planning or finding additional sources, I can help you with those issues. And the third step is to make the actual Google Slides. I will send out a YouTube video in which I explain how to make proper slides for those who need that guidance and help. I also explain various things such as what slides to use for your topics or how to format it properly. I also check each presenter's slideshows multiple times, and I send them the feedback so that they can improve their slides. The presenters also practice their presentations very often. I then conduct 2 practices prior to the event. So that's basically how the presenters start at choosing a topic and how they end up eventually presenting. So we had a great event today. Thank you everyone for attending the 4th STEM Fair. Thank you to all the presenters for presenting about great topics and making it a great event. Thank you to Professor Gain and Professor Brian for taking your time and creating the guest speaker messages. Thank you to Akhil and Aria for joining to assist with the presenters. And I hope to see you all in the next event in November. And you can check my site, stemfairs.com, for specific dates for future events and more information. Bye, everyone, and thanks for watching.